floor is yours, Patricia. Thank you.
There's a mic and
Okay. I'm taking. Good afternoon. I'm sure I've used 1 minute for the mic now. Yeah, so the presentation is titled Comparative Analysis of HVAC Energy Performance in Educational Facilities. We're using a BIM and BEM integration, that's Building Information Modeling and Building Energy Modeling integration. So I'm Patricia Q, Assistant Professor at the University of Florida. This one's okay. Okay, so to explain why we are doing that, BEM simulates whole building energy. We want to look at the building geometry, the materials, occupancy, and then we're using ASHRAE standards for our case study. And then we'll also look at some statistical testing with one-way ANOVA. Okay, let me wait for you. I hope you add my time. Okay, so we have some examples of previous studies that have used the ANOVA to test their studies, or they've integrated ANOVA in their methodologies. And so in this novel case study, we're combining BIM, BEM, and then ANOVA for a robust framework to evaluate HVAC alternatives. So we know we use HVAC for conditioning and distributing air within the building. So we want to see how that can improve energy efficiency. Okay, so for our case study, the location is in Ghana, in Africa, so I'm trying to wear Ghanaian attire. And so it's a case study of a residential school in Amoyaw-Brown in Ghana. And then we're using a student dormitory. We can see the drawings over here, the floor plan and some the section and then the views. And so this building can house 132 students. We developed the BIM model in Revit, Autodesk Revit, and then we export the features into eQuest for energy simulation. And so validating them by checking the geometry, the zoning, and the area of the building. She's trying to get it to stream, I think. So, let's see. Okay, and then the material properties. I hope. Okay, so in this slide, we're looking at the occupancy, the things that were considered in the simulation: occupancy, lighting, the equipment, and then the schedule. So occupancy times for these dormitories. And then internal loads follow the ASHRAE standard, ASHRAE 90.1. There are recommendations for the lighting, the settings for the lighting and the equipment. And then the set points are also between 75 to 78 degrees Fahrenheit. And then we have 4 types of HVAC systems with 40 simulations, so 10 for each type. And looking at other studies to choose the number of simulations. And then we use one-way ANOVA to test among these 4 types to see if there's significant difference between their performance. And then the metric is the EUI, the energy use intensity. So when you measure the energy over the square foot of the building, it can tell you, give you a standard to compare within the building. So this table is just showing us the lighting power density, the minimum and maximum, the equipment power density, the temperature set points there. So we have this method diagram to show the workflow, that we prepare the model, we export the data to eQuest, we do some thermal zone mapping, material and envelope mapping, and then verify the model. And then talking about the standards again, the equipments, and then the ANOVA, when you do the test, you also verify the tests, and then you have some residual data. So when we do this validation, we're saying we're making sure it's robust and reliable. Okay, so here we are seeing the tests and the results showing us which one was the strongest factor influencing the EUI, that's the HVAC. And then we confirm that there's significant difference among the performance of the 4 scenarios, giving the results. And then we see that the HVAC explained 96.9% of the variation. And then we look at HVAC being the dominant determinant of predicted energy consumption. So the 4 types, we'll explain more in the future slides, what exactly they look like. But looking at the diagram here, you'll see that this is a maximum, and then we have the minimum. And then when we look at the comparing it to find the difference, you do a Tukey test to see which ones are different from each other. So we see that the chilled water is the least energy efficient option for the case study. And so the study is demonstrating significant difference between the EUI of the 4 systems, and this is a critical decision for which system we can use in these dormitory buildings. And so in the future work, we look at integrating life cycle costs, operational constraints, and the digital twin capabilities to study them. Thank you.